Picture this: a massive stone needle piercing the sky, carved from a single block of red granite, standing taller than a 10-story building. This isn't some futuristic monument. It's an Egyptian obelisk crafted over 3,000 years ago, and yet its very existence leaves modern engineers scratching their heads. How did a civilization without cranes, without steel, without even the wheel, manage to quarry, transport, and erect these colossal structures with such precision? The truth is, we still don't have all the answers, and that's what makes these ancient marvels so utterly fascinating. Think about the numbers for a moment. Some of these obelisks weigh more than 400 tons. That's like lifting 200 cars into the air and balancing them perfectly upright. The largest one ever attempted, the Unfinished Obelisk of Aswan, would have tipped the scales at nearly 1,200 tons if it had been completed. But here's the thing: the Egyptians didn't just carve these stones, they moved them hundreds of miles across deserts and rivers, and then raised them with an accuracy that rivals modern laser-guided construction. How? That's the million-dollar question. Even today, with all our technology, replicating their feats would be a staggering challenge. So what secrets did the ancient builders know that we've somehow lost to time? Were they using forgotten tools, advanced techniques, or something even more extraordinary? This isn't just a story about stones and sand. It's a puzzle that connects us to the brilliance of a civilization that refused to be limited by what seemed impossible. As we unravel the mysteries of these towering enigmas, you'll discover why scholars and engineers still debate their construction, why some theories sound like they're straight out of a science fiction novel, and how these silent giants continue to defy explanation. Ready to step into the shadows of history and uncover the truth? Let's begin. To understand why obelisks still baffle us today, we have to step back into the world that created them. A world where these towering stones weren't just architectural feats but sacred bridges between humanity and the gods. The ancient Egyptians believed obelisks captured the very essence of the sun god Ra, their pointed tips symbolizing rays of sunlight piercing the heavens. That's why you'd often find them in pairs, flanking temple entrances like divine gatekeepers. The hieroglyphs covering their surfaces weren't mere decoration, they were prayers carved in stone, meant to channel the gods' power into the earth. The earliest obelisks appeared during the Old Kingdom, around 4,500 years ago, but it was the New Kingdom, 1,000 years later, that perfected their design. Imagine the ambition: workers in the quarries of Aswan chiseling away at mountains of red granite, knowing a single mistake could shatter weeks of labor. These weren't just any stones, they were chosen for their durability, their color resembling the fiery glow of the sun at dawn. And yet, the real marvel isn't just the carving. It's the logistics. How do you move a 400-ton needle of rock across hundreds of miles of desert without modern machinery? Some theories suggest they used sledges, lubricated with water or mud, dragged by teams of laborers. Others propose they may have floated the obelisks down the Nile on massive barges during the annual floods. But here's where it gets even stranger. Once they reached their destination, how did they stand them upright? Ancient texts mention ramps and counterweights, but no surviving records detail the exact process. Modern engineers have tried replicating these techniques, only to find that even with today's knowledge, it's a near impossible task. The precision is staggering. The base of an obelisk had to fit perfectly into its pedestal, with less room for error than the width of a coin. One wrong move, and the entire structure could topple, crushing everyone below. What's most haunting isn't just the how, it's the why. Why dedicate so much labor, so much risk to these towering stones? For the Egyptians, the answer was simple. Obelisks were cosmic anchors meant to last for eternity. And in a way, they've outlived their creators by millennia. Yet for all we've uncovered, their full secrets remain locked in the past, waiting for the next clue to surface. Standing in the Aswan quarries today, you can still see the ghosts of unfinished obelisks, massive rectangles of granite half-carved from the living rock, abandoned mid-creation like frozen snapshots of ancient labor. These haunting remnants hold the first clues to a mystery that has stumped archaeologists for centuries. How did workers, armed with nothing more than stone hammers and copper chisels, manage to extract 100-ton blocks with such surgical precision? The answer lies in the scars they left behind. Look closely at the grooves surrounding the unfinished obelisks, and you'll notice something extraordinary. The Egyptians didn't cut the stone. They pounded it. Teams of laborers would have spent months, maybe years, hammering trenches around the intended block using dolerite balls, a rock harder than granite. Think of it like sculpting with 1,000 tiny, relentless taps. Each strike would have sent vibrations through the stone, slowly fracturing it along natural fault lines. But here's what defies logic. Despite this brute force method, the surfaces they achieved were almost glass smooth. Modern engineers have tried replicating the technique, only to end up with jagged, uneven results. So what did the Egyptians know that we don't? Some researchers point to an ingenious polishing method involving quartz, sand, and water, essentially turning abrasion into an ancient form of sandpaper. Others speculate about lost tools, perhaps a copper alloy we haven't rediscovered, or a technique involving heat to soften the granite temporarily. But the most baffling detail: the absence of tool marks. On many finished obelisks, the surfaces are so flawless that they reflect light like mirrors, a level of perfection that even today's diamond-tipped tools struggle to replicate without leaving traces. Then there's the sheer scale of the operation. The unfinished obelisk at Aswan, if completed, would have stretched 137 feet, taller than a 13-story building. Just freeing it from the bedrock would have required removing over 2,000 tons of excess stone, and yet the Egyptians weren't just hacking blindly. Laser scans reveal that their trenches followed the natural grain of the granite with near-scientific accuracy, minimizing waste and preventing catastrophic cracks. It's as if they could see inside the stone, anticipating weaknesses invisible to the naked eye. What's often overlooked is the human cost of this precision. The quarries were brutal workplaces where temperatures could soar past 120 degrees. Workers toiled in shifts around the clock, their progress measured in inches per day. One misjudged strike could split the obelisk irreparably, wasting years of labor, and yet they persisted, driven by a belief that these stones were more than monuments. They were divine vessels meant to endure for eternity. That devotion might explain the perfectionism, but it doesn't fully solve the riddle of their methods. Perhaps the most humbling realization comes when you compare ancient and modern techniques. Today, we'd use diamond saws and computer-guided machines to quarry granite. The Egyptians used rocks, patience, and an almost supernatural understanding of materials. Their primitive tools achieved results that still make engineers pause. Were they leveraging lost knowledge of vibration harmonics? Did they have access to a polishing secret now buried in the sands? Or is the answer simpler, a mastery of craft so refined that it transcended technology? Every chip in the Aswan quarries whispers another piece of the puzzle, daring us to look closer. Transporting an obelisk wasn't just a feat of engineering. It was a high-stakes ballet of coordination, brute force, and ingenuity. Picture a slab of granite heavier than a blue whale, needing to travel hundreds of miles across blistering deserts and unpredictable river currents. The most plausible theory, a combination of sledges, rollers, and the lifeblood of Egypt itself, the Nile. Workers likely dragged the obelisk on wooden sledges, lubricating the path with water or wet clay to reduce friction. But here's the catch: even with hundreds of laborers pulling, the weight distribution had to be perfect. A single uneven tug could snap ropes or send the stone careening into the sand, crushing anyone in its path. Then came the river. Loading a 100-ton monolith onto a barge without modern cranes seems impossible, yet hieroglyphs hint at how it might have been done. Some scholars believe the Egyptians built temporary canals or ramps alongside the Nile, submerging barges beneath the obelisk and then refloating them. Imagine the precision required timing the river's currents, ensuring the barge didn't capsize under the shifting weight. One reconstruction attempt in the 1990s ended disastrously when a scale model obelisk tipped a barge, sending it to the riverbed. Yet the ancients transported dozens of these stones, seemingly without incident. What's even more baffling is the unloading process. At Luxor or Karnak, the obelisk had to be slid onto land without splintering the barge or cracking the stone. Some theories suggest they used counterweighted levers or sand-filled pits to lower it gradually. But with no surviving diagrams or manuals, we're left reverse engineering their methods from fragments of art and guesswork. Modern engineers have calculated that the forces involved would push primitive ropes and wood to their absolute limits, so how did the Egyptians manage it repeatedly? Perhaps the most telling clue isn't in the successes but the absence of failures. If a barge had sunk or an obelisk shattered, we'd expect evidence: broken stones in riverbeds, abandoned transport routes. Yet the archaeological record is eerily silent. This wasn't trial and error, it was a perfected system honed over generations. Were there specialized tools we haven't discovered, secret techniques passed orally among craftsmen, or did they understand physics in ways we're only beginning to grasp? Every unbroken obelisk standing today is a silent testament to a logistics puzzle we still can't fully solve. Now comes the most breathtaking act in this ancient engineering drama: taking a multi-ton stone monolith lying flat on the ground and standing it upright with nothing but human muscle and primitive tools. Picture the scene. After months of backbreaking labor moving the obelisk to its sacred site, workers faced their most dangerous task. The base of an obelisk typically measured just a few feet across, barely enough to balance a dining table, let alone a skyscraper of stone. One slight miscalculation in the angle, one uneven pull on the ropes, and the entire structure could come crashing down, shattering on impact and likely killing dozens. The most widely accepted theory involves an enormous earthen ramp built at a gradual incline. Workers would have slowly dragged the obelisk up this slope, perhaps using a combination of wooden sledges and rollers. As the stone reached the summit, teams stationed on either side could have used ropes to carefully pivot it into an upright position over its pedestal. But here's the problem: no such ramps have ever been found near standing obelisks. The amount of material required would have left unmistakable archaeological traces, yet the ground around these monuments shows no evidence of massive earthworks. Alternative theories suggest the Egyptians might have used counterweights, huge sand-filled containers that could be gradually emptied to provide controlled leverage. A wall carving from the Deir el-Bahari temple complex shows what some interpret as a giant wooden frame being used to raise an obelisk, but the image is highly stylized and lacks critical details. Modern attempts to recreate this method have yielded mixed results, often requiring adjustments that the ancients wouldn't have had the luxury of making. Perhaps most perplexing is the precision of the final placement. The base of an obelisk had to slot perfectly into a prepared socket in the pedestal, with tolerances sometimes less than a quarter of an inch. How did they achieve such accuracy without modern surveying tools? Some researchers speculate about water levels or shadow tracking devices, but no such instruments have been discovered in the archaeological record. The true stroke of genius may have been in the preparation. Examination of pedestals reveals shallow depressions carved around the edges, possibly for wooden stabilizing beams that could be adjusted during the raising process. The Egyptians might have also used temporary guide walls to prevent lateral movement, removing them once the obelisk was secure. Yet even with these precautions, the margin for error was vanishingly small. What's often overlooked is the psychological aspect of this operation. Unlike quarrying or transport, which could be done gradually, raising an obelisk was an all-or-nothing moment requiring perfect coordination among hundreds of workers. The tension must have been unbearable, months of labor culminating in a single, irreversible action. Success meant eternal glory, failure meant catastrophe. That pressure alone makes their consistent achievements even more remarkable. Modern engineers have calculated that the forces involved in raising a 200-ton obelisk would require at least 750 people pulling simultaneously on ropes, a logistical nightmare even with today's communication technology. Yet the Egyptians performed this ritual repeatedly across centuries, leaving behind monuments that still stand perfectly plumb after millennia. Their methods may be lost to time, but the results speak for themselves, a triumph of collective human ingenuity that continues to humble our technological age. The alignment of Egyptian obelisks isn't just impressive, it's mathematically eerie. These towering stones didn't just stand upright, they locked into place with celestial precision, their shadows tracing paths that mirrored the movements of the sun, moon, and stars. Take the obelisk at Heliopolis, for instance. During the equinoxes, its shadow would fall perfectly along a ceremonial pathway, as if the stone itself was drawing a line between earth and sky. This wasn't accidental. The Egyptians designed these monuments to act as giant sundials, calendars, and even cosmic compasses, all carved from a single block of stone. But here's what stumps researchers. Achieving this level of accuracy required an intimate understanding of astronomy, far beyond what we typically attribute to ancient civilizations. Modern surveys reveal that some obelisks are aligned to true north with deviations of less than half a degree, a margin of error that would challenge today's engineers armed with GPS. How did they do it without telescopes or precise angle measuring tools? One theory points to the Merkit, an ancient Egyptian device resembling a simple plumb line. Used alongside sighting rods, it could have helped track the movements of stars like Sirius or the circumpolar constellations. Yet even with these tools, the consistency of their alignments across centuries suggests a systemized knowledge, possibly encoded in priestly texts that haven't survived. The real marvel lies in the purpose behind this precision. Obelisks weren't just scientific instruments, they were spiritual conduits. At Karnak, the central obelisk's alignment with the winter solstice sunrise meant its shadow would touch the inner sanctum of the temple, a moment believed to channel Ra's power directly into the sacred space. This fusion of astronomy and theology reveals a civilization that saw the cosmos as a living, interconnected force. They didn't just observe the stars, they choreographed their architecture to dance with them. What's even more baffling is the scalability of their methods. From the earliest small obelisks to the later colossal ones, the astronomical alignments hold true, implying a standardized system passed down through generations. Recent laser scans of the Luxor obelisks show that their east-west orientations match solar positions calculated using modern software, with discrepancies smaller than the width of a finger. This consistency hints at a level of record-keeping and mathematical rigor we're only beginning to appreciate, yet for all we've deciphered, gaps remain. No surviving texts explain how they compensated for atmospheric refraction or the slight wobble in Earth's axis over millennia, factors that would have subtly shifted alignments over time. Did they recalibrate their monuments periodically, or did they possess a geometric framework sophisticated enough to account for these variables? The silence of the archaeological record leaves us with a tantalizing paradox: structures that speak volumes about their creator's genius but whisper nothing of their methods. Perhaps the most humbling realization is how these ancient architects thought in scales we rarely do today, where we see separate disciplines: engineering, astronomy, religion. They saw a single, unified language of stone and sky. Every perfectly aligned obelisk is a testament to that holistic vision, a reminder that precision isn't just about tools, it's about intention. And in that, the Egyptians may have been the most advanced civilization of all. The mystery deepens when we examine the tools, or rather, the lack of them. Archaeologists have uncovered countless artifacts from ancient Egypt, from golden burial masks to intricate jewelry, but one glaring absence stands out: the implements needed to shape granite with such surgical precision. The copper chisels commonly found in excavations work beautifully on limestone or sandstone, but granite, a rock so hard it ranks just below diamond on the Mohs scale, would have reduced these soft metal tools to useless nubs within minutes. This leaves us with a paradox: without iron or steel, which weren't widely used in Egypt until centuries later, how did workers achieve those mirror-smooth surfaces and razor-sharp edges? Some researchers propose they might have employed dolerite pounding stones, as seen in the Aswan quarries, but these would have left distinctive pockmarks, not the glassy finishes found on finished obelisks. Even more perplexing is the near-total absence of tool marks on many monuments. It's as if the granite was molded rather than carved, raising wild but tantalizing theories. Could the Egyptians have discovered a way to temporarily soften the stone using heat or chemical treatments, a technique lost to time? The speculation doesn't end there. A handful of fringe theorists point to unusual wear patterns on certain obelisks that resemble what modern diamond-tipped saws might produce, sparking debates about possible advanced machining. Mainstream Egyptologists dismiss these claims, attributing the patterns to natural erosion or later restoration work. Yet the core question remains: if conventional tools couldn't account for the precision, what alternatives existed? One overlooked clue might lie in the Egyptians' mastery of abrasives. Crushed quartz sand, when mixed with water and applied under pressure, can grind granite surprisingly efficiently. Experiments show that a team using sand-lubricated copper drills could bore through granite at a rate of about 2 millimeters per hour, painstakingly slow, but feasible for a civilization that measured projects in decades rather than days. This could explain the absence of deep chisel marks, as abrasion leaves subtler traces. But even this theory stumbles when confronted with the sheer scale of obelisk production. Polishing an entire 400-ton monolith this way would have required manpower and time on an almost unimaginable scale. Perhaps the most compelling evidence of all isn't in the tools themselves, but in the workers' approach. Modern engineers tend to think in terms of force and resistance, pushing materials to their limits. The Egyptians, by contrast, might have worked with the stone's natural properties, exploiting microscopic fractures or sonic vibrations to ease shaping. Some carvings in temples depict what appear to be curved copper saws, hinting at specialized tools we've yet to rediscover. The silence of the archaeological record speaks volumes. Either we're missing critical pieces of the puzzle, or the ancient craftsmen achieved perfection through sheer skill. a level of artistry so refined it rendered its own tools invisible. Every unchipped edge, every flawless surface whispers the same unsettling truth. We still don't know how they did it, and that's what makes these stones more than monuments. They're challenges cast in granite, daring us to rethink what ancient hands were truly capable of. Buried in the bedrock of Aswan lies a sleeping giant, the largest known ancient obelisk ever attempted, frozen in time mid-creation. Stretching 137 feet long and weighing an estimated 1,168 tons, the Unfinished Obelisk is a humbling reminder that even the Egyptians, with all their ingenuity, sometimes met their match. What makes this abandoned project so extraordinary isn't just its size. It's the snapshot it provides of the obelisk building process caught in action, like pressing pause on history itself. Walk around the trenches surrounding the half-carved monolith, and you're literally tracing the footsteps of ancient stoneworkers. The grooves they hammered out with dolerite tools are still visible, their width just barely wide enough for a person to squeeze through. This was no haphazard excavation, every strike was calculated. Laser scans reveal how the workers followed the natural grain of the granite, exploiting weaknesses in the stone's structure to minimize effort. But then, disaster struck. Deep cracks began spiderwebbing through the base, rendering the entire project unusable. Some scholars believe a hidden flaw in the bedrock doomed it from the start. Others think an overzealous strike might have triggered the fractures. Either way, the obelisk was left where it lay, a silent witness to the razor-thin margin between triumph and failure. The real puzzle isn't why they abandoned it, it's how they planned to move it. At nearly 3 times the weight of any successfully transported obelisk, this would have been the ultimate test of Egyptian engineering. No existing ramp or barge designs could have handled such mass. Some theories suggest they might have planned to split it into smaller sections, but the uniformity of the carving implies it was meant to remain whole. Others propose an elaborate system of counterweighted levers, slowly inching it toward the Nile on a reinforced sledge, but the truth is we'll never know. The Unfinished Obelisk is like a cliffhanger in an ancient manuscript, the methods hinted at but never fully revealed. What's often overlooked is the psychological impact of this failure. In a culture where monumental projects were acts of devotion, abandoning an obelisk meant more than wasted labor. It risked divine displeasure. Yet there's no evidence of ritual attempts to appease the gods, no inscriptions blaming supernatural forces. The workers simply walked away, as if acknowledging the limits of even their extraordinary skills. This humility is perhaps the most surprising legacy of the Unfinished Obelisk. For all their achievements, the Egyptians weren't infallible. They pushed boundaries until the boundaries pushed back. Modern engineers have studied the cracks with seismic sensors, revealing just how close the stone was to catastrophic failure. The fractures run deep, following crystalline structures invisible to the naked eye. This raises an eerie possibility. Had the obelisk been completed and moved, the stresses of transport might have caused it to shatter mid-journey with deadly consequences. In that sense, the workers' abandonment might have been a lucky escape, yet their ambition still towers over us, a reminder that some questions, like the obelisk itself, remain rooted in the earth, waiting. The precision of an Egyptian obelisk isn't just skin deep, it's etched into its very bones. Take a closer look at one of these towering monuments, and you'll notice something extraordinary. The sides aren't just straight lines. They taper inward at an exact angle, narrowing gracefully toward the sky like a sunbeam made solid. This isn't artistic intuition, it's mathematical mastery. The Egyptians didn't just carve obelisks, they encoded them with geometric perfection, using ratios so precise that modern architects still study them in awe. The secret lies in the numbers. Every obelisk follows a strict proportion, typically a height-to-base ratio of about 10:1. This wasn't arbitrary. The ancients understood that this specific taper distributed weight optimally, preventing stress fractures while creating that iconic silhouette against the horizon. Even more impressive is the pyramidion, the gleaming gold-capped tip. Its angles were calculated to catch the first and last light of day, acting as a celestial mirror. Measurements of surviving pyramidions revealed deviations of less than half a degree across examples separated by centuries and miles. But here's the real puzzle. How did they maintain this consistency without standardized rulers or protractors? Surviving mathematical papyri like the Rhind mathematical papyrus show the Egyptians were fluent in geometry, using unit fractions and ropes to solve complex problems. Some scholars believe they employed a simple but brilliant method: knotted cords. By spacing knots at precise intervals along a rope, workers could create proportional guides for the obelisk's taper. Stretch the cord diagonally across the stone as they carved, and voila, a perfect angle, repeatable anywhere. Yet even this explanation has gaps. The precision of the pyramidion's facets suggests something beyond ropes and stakes. Recent 3D scans of the Lateran obelisk in Rome, originally from Karnak, reveal that its faces aren't flat planes but subtly curved, a technique called intosses also seen in Greek columns. This curvature compensates for optical distortion, making the obelisk appear perfectly straight from ground level. Achieving this effect required not just math, but an understanding of human perception, an architectural sleight of hand carved in stone. The most tantalizing clue might be hiding in plain sight. Temple reliefs occasionally depict workers holding peculiar T-shaped tools. Some researchers argue these were early surveying instruments, perhaps used with shadow angles to verify alignment. Others point to the mysterious Egyptian triangle, a right-angled shape with sides in a 3:4:5 ratio, found repeatedly in their monuments. Could this have been their geometric Rosetta Stone, a template for flawless proportions? What's undeniable is the result. Across dynasties, across quarries, the obelisks speak a common mathematical language. Whether erected in Thebes or Heliopolis, they share the same sacred ratios, as if every craftsman had access to an invisible blueprint. Perhaps they did not on papyrus, but in oral traditions lost to time. The stones remain silent witnesses to a system that turned granite into poetry and mathematics into monuments. The notion that the Egyptians might have wielded tools or techniques beyond our modern understanding lingers, like a tantalizing shadow across these ancient stones. Among the most persistent theories is the idea of sonic levitation, that workers used sound frequencies to somehow lighten or manipulate the massive obelisks. Ancient texts mention the use of chanting and rhythmic pounding during construction, fueling speculation that these weren't just rituals but practical applications of acoustic physics. Proponents point to examples from other cultures, like the legends of Tibetan monks moving stones with trumpets, suggesting a lost global knowledge of vibrational engineering. Yet for all its allure, no archaeological evidence, no tuning devices, no resonating chambers has ever been found in Egypt to substantiate the claim. Then there's the chemical theory, the idea that the Egyptians possessed a formula, perhaps plant-based or mineral, capable of temporarily softening granite. Some point to the mysterious liquid stone described in a handful of temple inscriptions, while others cite the unnaturally smooth surfaces of certain obelisks as potential proof. Modern experiments with oxalic acid, found naturally in plants like rhubarb, have shown it can etch granite under controlled conditions. But scaling this up to quarry-sized applications presents a host of problems, not least the sheer volume needed to affect a 400-ton monolith. Without traces of such substances in tool marks or quarry sites, the theory remains speculative at best. What's often overlooked in these discussions is the human element. The ancient Egyptians weren't just technicians, they were master observers of nature. Some researchers propose they might have exploited thermal expansion, heating the stone with fire, then rapidly cooling it with water to create fracture lines. This wouldn't require advanced tech, just an intimate knowledge of material properties. Similarly, the precision of their drilling, seen in artifacts like the granite boxes of the Serapeum, hints at a possible mechanical advantage we've yet to rediscover. Core samples from these boxes show spiral grooves consistent with a weighted drill, but the exact mechanism and efficiency remain unclear. The most sobering reality is the lack of physical evidence for any of these lost technologies. No workshop remnants, no tool fragments, no chemical residues in quarries align with the more exotic theories. Mainstream archaeology maintains that the Egyptians achieved their feats through sheer skill, patience, and an almost supernatural understanding of leverage and geometry. Yet the absence of evidence isn't always evidence of absence. The irony is that if such advanced methods did exist, they might have left no trace precisely because they were so effective. Perhaps the truth lies somewhere between the pragmatic and the extraordinary. The Egyptians clearly had access to knowledge passed down through generations, refined through trial and error. Maybe their greatest technology wasn't a device or a chemical, but a system of collective memory, oral traditions, apprenticeship models, and a culture that elevated craftsmanship to sacred art. In the end, the stones themselves are the only witnesses, and they guard their secrets as fiercely as the desert guards its dead. Look at any Egyptian obelisk under the night sky, and you're not just seeing a monument, you're staring at a frozen star map. These towering stones didn't just point toward the heavens, they locked into celestial rhythms with an accuracy that would make modern astronomers double-check their instruments. At Karnak, the twin obelisks of Hatshepsut frame the winter solstice sunrise so precisely that on that single morning each year, their shadows converge at the temple's innermost altar, as if drawing the sun's power directly into the sacred space. This wasn't just decoration, it was a celestial handshake between earth and sky, engineered down to the inch. But here's what's truly mind-bending. Achieving this required more than just marking where the sun rose one morning. The Egyptians tracked solar and stellar movements over generations, compensating for subtle shifts in Earth's axis that would have thrown alignments off by fractions of a degree over centuries. Take the Heliopolis obelisk, originally positioned to align with the star Sirius. When the star's heliacal rising, its first visible appearance at dawn signaled the annual Nile flood. The obelisk's shadow would touch a specific point in the temple precinct, triggering ceremonies tied to the agricultural cycle. Modern simulations show this alignment held for over 1,000 years with minimal drift. That's not luck. It's mathematical foresight on a cosmic scale. The deeper mystery lies in how they standardized this knowledge. Across dozens of obelisks spanning hundreds of miles and centuries of construction, the same astronomical principles recur. At Luxor, the obelisks align with the constellation Orion's belt, mirroring the pyramid fields at Giza. In Abydos, they frame the bright star Canopus, sacred to the navigational cults of the Nile. This consistency suggests something radical: a nationwide celestial grid, where obelisks acted as both ritual markers and survey points, anchoring temples to an invisible cosmic blueprint. What's often overlooked is the practical genius behind the spiritual symbolism. These alignments weren't just ceremonial, they functioned as a colossal, stone-built calendar and compass. The slight daily shift in an obelisk's shadow could mark not just seasons but precise dates for planting, flooding, or religious festivals. Some researchers believe the pyramidions' gold caps weren't merely decorative, they may have acted as reflective markers, creating glints visible from distant observation, points to synchronized rituals across sites. Yet for all we've decoded, gaps remain. How did they compensate for atmospheric refraction, the bending of light near the horizon that subtly alters a star's apparent position? Why do some obelisks show alignments to stars that wouldn't have been visible due to precession, the slow wobble of Earth's axis? The unsettling possibility is that they understood celestial mechanics we only rediscovered millennia later, encoding that knowledge in stone rather than scrolls. The most humbling realization isn't just their technical skill, it's their vision. Where we separate science and religion, the Egyptians saw them as one language. An obelisk wasn't just a sundial or a shrine. It was a bridge between dimensions, its shadow tracing the handwriting of the gods across the earth. In that light, every aligned obelisk is a question carved in granite. How much of their cosmic wisdom have we yet to uncover? To grasp why obelisks captivated the ancient Egyptian imagination, you have to see them not as mere monuments but as living symbols, stone embodiments of cosmic forces. Their slender, tapering form wasn't just an aesthetic choice. It mirrored the sun's rays piercing through clouds at dawn, a visual hymn to Ra, the sun god. Each obelisk was a frozen beam of sunlight, anchoring divine energy to the earth. But the symbolism ran deeper. The pyramidion at its peak, often sheathed in electrum, a shimmering alloy of gold and silver, acted as a literal lightning rod for celestial power, glittering so brightly in the sunlight that it could be seen for miles. This wasn't just decoration, it was a beacon, a way to shout across the landscape. Here, the gods touch the earth. The hieroglyphs covering every inch of these monuments weren't random carvings either. They formed a sacred tapestry, weaving together the pharaoh's deeds, prayers to the gods, and even what some researchers suspect are subtle construction clues. Take the obelisk of Thutmose III at the Lateran in Rome. Its inscriptions include cryptic references to the measuring of the heavens and the path of the mason's hand. Could these be poetic metaphors, or might they hint at forgotten techniques? One tantalizing passage speaks of the rope that stretches the sky, which some interpret as a nod to the knotted surveyor's cords used to align temples with stars. Yet for all we've translated, the full meaning remains just out of reach, locked behind layers of religious symbolism. The obelisk's role in creation myths adds another layer of mystery. In the Heliopolitan cosmogony, the first land was said to have emerged from primordial waters as a mound, a shape echoed in the obelisk's base. Its four sides aligned with the cardinal directions, turning each monument into a miniature cosmos, a recreation of the moment order triumphed over chaos. This wasn't just philosophy, it was architecture as theology. When a pharaoh erected an obelisk, he wasn't just building, he was reenacting the birth of the world itself. But perhaps the most enduring symbol is the obelisk's shadow. Unlike modern skyscrapers that cast shifting, impersonal patterns, an obelisk's shadow moved with purpose. At Karnak, calculations show the shadow of Hatshepsut's obelisk would have traced a perfect path to the shrine of Amun-Ra during the summer solstice, a celestial handshake between god and king. The precision suggests the shadows were part of the design, a way to animate the stone with the sun's daily journey. What's striking is how these symbols transcended time. Even when later pharaohs usurped obelisks, carving their names over predecessors' inscriptions, the core meaning remained untouched. The stones outlived dynasties, their messages weathering political upheavals and foreign conquests. Today, as we stare at these silent sentinels, we're left with a paradox. The more we decode their symbols, the more we realize how much we've yet to understand. The hieroglyphs may give us words, but the true language of obelisks is written in sunlight, stone, and shadow, a code we're still learning to read. The Romans didn't just admire Egyptian obelisks, they became obsessed with them, hauling at least 13 of these towering stones across the Mediterranean to plant them in Rome like trophies. Imagine the audacity. After centuries of standing in Egyptian temples, these sacred monoliths were uprooted and shipped thousands of miles to glorify emperors who'd never set foot on the Nile. But here's the twist: while the Romans managed the feat, their methods reveal just how much of the original Egyptian craftsmanship remained a mystery, even to history's greatest engineers. Take the Lateran obelisk, the tallest ancient obelisk in existence. Originally standing in Thebes, it was dragged to Alexandria by Emperor Constantine in the 4th century, then shipped to Rome in a specially built vessel so massive it was described as a floating mountain. Roman engineers had to solve problems the Egyptians never faced, like navigating open seas with a 150-foot stone spire balanced precariously on deck. Contemporary accounts describe how they ballasted the ships with tons of grain to stabilize them, a clever trick, but one that pales next to the Egyptians' seamless river transports. What's most telling are the mistakes. Several Roman repurposed obelisks show cracks or misalignments absent from their Egyptian counterparts. The Vatican obelisk, for instance, bears stress fractures near its base, evidence of struggles during re-erection. While the Egyptians used precise pedestal sockets, the Romans often improvised with metal clamps and lead fillings, a brute force approach that lacked finesse. Even their celebrated achievement of mounting obelisks on spina, the central dividers of circuses, relied on external supports the original builders would have scorned. The starkest contrast lies in the numbers. Where Egyptian obelisks routinely weighed 300 to 400 tons, the Romans focused on smaller specimens, rarely exceeding 200 tons. The few exceptions, like the Lateran obelisk, required such Herculean effort that they were left unfinished for decades. It's as if the Romans hit an invisible ceiling, one the Egyptians had shattered millennia earlier. Why the gap? Perhaps because the Romans saw obelisks as political statements, while the Egyptians treated them as divine instruments. Without the sacred urgency that drove pharaonic engineers to perfection, Roman efforts were impressive but utilitarian. They used cranes, pulleys, and sheer manpower technologies the Egyptians supposedly lacked, yet never matched the original celestial precision. The most haunting evidence sits in ruins. At least 2 obelisks destined for Rome now lie at the bottom of the Mediterranean, lost in storms or mishaps. Their submerged skeletons whisper a humbling truth: some secrets of the ancients couldn't be stolen, only admired from afar. In the end, Rome's greatest tribute to Egyptian genius wasn't their triumphs, it was their failures. Modern engineers armed with cranes, lasers, and computer simulations have tried to recreate what the ancient Egyptians accomplished with copper chisels and ropes, and the results are humbling. Take the ambitious 2008 experiment by a team from the University of Liverpool. They attempted to raise a 25-ton replica obelisk using only ramps, wooden sledges, and manpower. After weeks of preparation, the moment of truth arrived. Workers strained against ropes, the obelisk inched upward. Then suddenly, the rope snapped, sending the stone crashing back to earth. The failure wasn't due to lack of effort. It was a stark reminder of how little we truly understand about the ancient methods. Similar experiments in Japan and Egypt have yielded partial successes, but always with caveats. In Aswan, archaeologists managed to move a 10-ton block using a sledge and wet clay, proving the basic principle works at a fraction of the scale. When teams tried scaling up to even 50 tons, the logistics collapsed under the weight. The real kicker: ancient inscriptions describe obelisks being raised in just hours during ceremonies. a feat modern physics struggles to explain without invoking lost techniques. One of the biggest stumbling blocks is the pedestal socket. Contemporary engineers have found that lowering an obelisk into its base with millimeter precision requires near impossible coordination. A team from MIT attempted it with a scale model and hydraulic lifts, tools the Egyptians decidedly didn't have, and still needed multiple tries to avoid catastrophic misalignment. This raises an unsettling question. Did the ancients possess a calibration method we've yet to rediscover? Some researchers point to the mysterious wooden, rocking frames depicted in temple carvings, suggesting they might have acted as primitive but effective guidance systems. The most telling failures, though, come from the quarry. Modern stonemasons using replica dolerite tools to extract granite report blistering fatigue after just hours of work, with progress measured in inches per week. Yet Egyptian quarries show evidence of teams producing finished blocks at rates that would outpace some modern operations. The difference might lie in the unseen details, the way workers alternated strikes to exploit the stone's crystalline structure, or the possibility of plant-based lubricants that reduced friction beyond what water alone could achieve. What's often overlooked in these experiments is the human factor. The Egyptians didn't just have techniques, they had generations of specialized knowledge passed through apprenticeships. A worker in the quarries wouldn't just know how to swing a hammer, he'd understand exactly where to strike based on the sound the stone made, a tactile wisdom no manual can replicate. Modern teams, for all their technology, lack this lived expertise. Perhaps the most profound lesson from these attempts isn't about ropes or ramps, but about redefining what we consider advanced. The Egyptians achieved precision not with complexity, but through an intimate dialogue with their materials, listening to the stone, adapting to its whims. In an age obsessed with high-tech solutions, their greatest innovation might have been something far simpler, patience perfected into an art form. Every failed modern reconstruction whispers the same truth. Some secrets aren't just about how you build, but how you see. At the very pinnacle of every Egyptian obelisk sat its crowning glory, the pyramidion. This wasn't just a decorative cap, it was the exclamation point on a monumental sentence carved in stone. Crafted from electrum, a shimmering alloy of gold and silver, these pyramidions caught the first and last light of day, transforming the obelisk into a towering beacon visible for miles. But here's what defies logic. These delicate crowns weren't just forged, they were fitted onto 100-ton monoliths with a precision that still baffles metallurgists today. Consider the challenges. Electrum, while beautiful, is notoriously soft compared to modern alloys. Hammering it into the pyramidion's perfect pyramidal shape without warping or cracking would have required a blacksmith's touch so refined it bordered on alchemy. Then came the real test, hoisting it onto the obelisk's peak, sometimes over 300 feet in the air. No cranes, no safety nets, just ropes, ramps, and human hands. One misstep could send months of painstaking craftsmanship tumbling into the sand. The secret might lie in the pyramidion's design itself. Examinations of surviving fragments reveal subtle ridges and grooves on their undersides, features that hint at a sophisticated locking mechanism. Some researchers believe the Egyptians used a form of heated lead or resin to securely bond the metal to the stone, creating a seal that could withstand desert winds and scorching heat. Others point to temple reliefs showing workers using what appear to be counterweighted platforms, allowing them to lower the pyramidion into place with millimeter precision. But the true genius wasn't just in the installation, it was in the optical effect. The electrum's reflective properties weren't accidental. On clear days, the pyramidion would have blazed like a second sun, its light visible from distant cities. During festivals, the timing of its gleam could mark ceremonial moments. turning architecture into a celestial clock. The Pyramidion at Karnak, for instance, was positioned so that its midday reflection would illuminate the temple's inner sanctum precisely when the sun reached its zenith, a flash of divine approval engineered in metal and stone. What's often overlooked is the Pyramidion's fragility. Unlike the indestructible granite below, these golden caps were prime targets for looters and later civilizations. That's why so few survive intact. The ones we've recovered show signs of meticulous repair, suggesting the Egyptians maintained them with near religious devotion. Scratches and solder marks tell stories of priests scaling precarious heights to polish away corrosion or mend storm damage. Modern jewelers have tried recreating pyramidions using ancient techniques, only to hit roadblocks. The alloy ratios vary mysteriously from one obelisk to another, as if each batch was custom blended for specific light conditions. Some pyramidions contain traces of copper not for strength, but to tweak their reflective qualities, turning them into giant tuning forks for sunlight. This level of material science shouldn't exist in a civilization without spectrometers or chemistry labs, and yet the evidence gleams back at us from museum cases. Perhaps the most poignant detail comes from a scribe's account found at Heliopolis. It describes the final ritual of capping an obelisk, a ceremony where the pyramidion was raised at dawn, timed so that its first reflection would coincide with the sun clearing the horizon. In that moment, the obelisk was considered alive, its shadow and light now part of the cosmic dance. That such a fragile object could bear such weight of meaning is its own kind of miracle, one that outlasted empires, still whispering its secrets in gold and silver. The absence of sprawling worker settlements near Egypt's obelisk quarries presents one of history's most intriguing logistical puzzles. Unlike the pyramid builders' villages at Giza, with their bakeries, dormitories, and administrative records, the landscapes around Aswan and other granite sources show no signs of permanent housing for the armies of laborers needed to extract and shape these colossal stones. This forces us to reconsider everything we thought we knew about ancient labor organization. If workers weren't living on site full-time, how did they sustain the years-long effort required to quarry, transport, and erect these monuments? One compelling theory suggests the Egyptians operated with seasonal precision, timing quarry work to the Nile's annual flood cycle. During the inundation, when farming was impossible, farmers could have been drafted into temporary stoneworking crews, their agricultural skills repurposed for hauling and carving. This would explain the lack of permanent settlements. Workers returned home when the waters receded and fields needed tending. Hieroglyphs mention corvée labor, a system where citizens contributed mandatory service to state projects, often during agricultural downtime. It's a model of efficiency that modern gig economies might envy. No year-round payroll, just cyclical bursts of coordinated effort. But feeding thousands of workers, even temporarily, would have required staggering resources. Grain records from the reign of Ramses Roman III reveal stockpiles large enough to feed 20,000 workers for months, suggesting a well-oiled supply chain stretching from the Nile's delta to distant quarries. Archaeologists have uncovered traces of what might be mobile kitchens, clusters of fire pits, and pottery shards near work sites, far too small for permanent housing but ideal for rotating shifts. The key may have been decentralization. Instead of one massive camp, smaller, rotating teams could have worked in relays, reducing the need for extensive infrastructure. The real genius, though, lay in their division of labor. Tomb paintings depict specialized crews: stonecutters, rope makers, water carriers, each with distinct tools and attire. This wasn't a chaotic mob, but a precision-engineered workforce, possibly organized along military lines. A fragmentary papyrus from Deir el-Medina lists workers divided into left and right gangs, competing to outperform each other, with bonuses awarded for speed and quality. Modern project managers call this parallel work streams. The Egyptians perfected it 3 millennia ago. What's truly humbling is the absence of waste. At modern construction sites, piles of discarded materials and temporary structures litter the landscape. At Aswan, even the chippings from obelisk carving were recycled, crushed into roadbeds or mortar. This zero-waste efficiency hints at a level of planning that bordered on clairvoyance. Perhaps the greatest evidence of their organizational brilliance isn't what they left behind, but what they didn't. The silence of the archaeological record might not be a gap in our knowledge, but a testament to their ability to work with the land rather than against it, leaving no scars, only monuments. The Nile wasn't just a river to the ancient Egyptians. It was a liquid highway, a pulsing lifeline that may have held the secret to moving their most massive monuments. Picture this, an obelisk freshly carved from the Aswan quarries, weighing as much as a small battleship. Now imagine sliding it onto a barge without cranes or hydraulics. One radical theory suggests they didn't fight the weight, they let water do the work. By digging temporary canals or trenches alongside the Nile, workers could have floated the barge beneath the obelisk, then carefully flooded the area to lift the stone onto the vessel. As the water rose, the obelisk would have gently settled into place, supported by buoyancy rather than brute force. It's an elegant solution, but here's the catch. Not a single shred of archaeological evidence confirms this method was ever used. The Nile's annual floods add another layer to the mystery. These predictable inundations transformed the landscape, creating shallow lakes and expanding waterways far beyond the river's normal banks. Timing quarry work to coincide with the floods would have allowed workers to move obelisks on sledges across waterlogged ground, drastically reducing friction. Wall paintings from the tomb of Jehu'tihotep show a colossal statue being dragged on a sledge, with a worker pouring liquid, likely water, ahead of the runners. This simple trick could cut pulling force by half, turning an impossible haul into a manageable task. But obelisks weren't statues, they were longer, heavier, and far more unstable. A slight tilt during transport could send the stone plunging into the mud, burying it irretrievably. What's truly baffling is the precision required for water-based transport. Even a minor miscalculation in buoyancy could capsize a barge, sinking the obelisk to the riverbed. Modern engineers have calculated that stabilizing a 400-ton monolith on a wooden vessel would require near-perfect weight distribution, something the Egyptians seemingly achieved again and again without modern physics. Some researchers point to the mysterious Jed symbol found near quarry sites, often interpreted as a stabilization device. Could these have been primitive ballast markers, guiding workers on how to balance loads? The most tantalizing clue might lie in the stones themselves. Core samples from obelisk pedestals often show traces of silt and aquatic plant matter, materials that shouldn't be present if the blocks were solely dragged over land. This hints at partial water transport, perhaps a hybrid approach where obelisks were floated partway, then transferred to sledges for the final overland push. The logistics would have been staggering, requiring coordinated teams along the entire route to dig channels, monitor water levels, and adjust ropes. Yet for all these theories, the water hypothesis leaves gaps. Why haven't we found remnants of these temporary canals? How did they prevent barges from rotting under such immense loads? The Nile's secrets may have washed away with time, leaving us with only ripples of possibility, echoes of a technique so fluid, so perfectly adapted to the land, that it left no trace beyond the towering stones themselves. This absence of trial and error isn't just impressive, It's borderline unnerving. Think about other ancient megaprojects. The Maya built pyramids that occasionally collapsed mid-construction. The Romans left behind cracked arches and abandoned aqueducts. But Egypt's obelisks, not a single one we've found shows signs of catastrophic failure. No toppled giants half buried in sand. No shattered remains where a multi-ton stone once crashed to earth. Every known obelisk that left the quarry made it to its pedestal intact. This isn't just skill. It's like watching a tightrope walker cross a chasm blindfolded, over and over without ever wobbling. What makes this consistency even more baffling is the sheer audacity of the attempts. The unfinished obelisk in Aswan proves they pushed boundaries. That abandoned project shows they weren't infallible. Yet every completed obelisk we've studied, from the Lateran in Rome to the Luxor pair in Paris and Cairo, shares the same flawless execution. It's as if they cracked some universal formula for stonework early on and never deviated. Modern engineering thrives on iterative design: build, fail, improve. The Egyptians seem to skip straight to the perfected version, leaving no breadcrumb trail of prototypes. One theory suggests the secrets might lie in lost apprenticeship systems. Unlike today's classroom-based training, Egyptian stonemasons likely learned through years of hands-on mentoring, absorbing techniques refined over centuries. A master craftsman wouldn't just teach how to strike a chisel, he'd pass down the exact angle to hold it against granite, the rhythm of strikes to exploit natural fault lines, even the songs workers hummed to maintain perfect tempo. This oral tradition could explain the absence of written manuals. The knowledge lived in muscle memory and ritual chants, not papyrus. But here's the twist: even the most rigorous training can't account for the absence of freak accidents. Moving a 400-ton stone is like playing Jenga with a skyscraper. One slipped rope, one uneven patch of sand, and disaster strikes. Yet the archaeological record shows no evidence of these inevitable mishaps. This leads some researchers to speculate about ritual safeguards, perhaps ceremonies performed before each critical stage to double-check measurements or bless the ropes. A wall carving in Hatshepsut's temple depicts workers anointing an obelisk with what might be lubricating oil or sacred fluid. Was this practical physics disguised as religion? The most compelling clue might be hiding in plain sight: the quarries themselves. Laser scans of Aswan reveal that workers didn't just randomly hack at granite. They probed the bedrock like surgeons, mapping hidden fissures with sounding stones before making a single cut. This preemptive troubleshooting would have weeded out flawed stones before they became doomed projects. Modern engineers call this failure mode analysis. The Egyptians might have practiced it 3,000 years ago with nothing more than keen ears and patience. Perhaps the real answer lies in redefining what we consider mistakes. The unfinished obelisk wasn't a failure. It was a lesson frozen in time, showing how workers identified critical flaws before they became catastrophes. In an era when stone was eternal and errors unthinkable, the greatest skill wasn't just knowing how to succeed, but when to walk away. Every standing obelisk isn't just a monument to what they achieved, it's a silent testament to what they refused to risk. The notion that Egyptian engineers might have harnessed simple machines in groundbreaking ways lingers like an unsolved equation. Among the most compelling theories is the sandpit method, a deceptively elegant solution where workers could have gradually emptied containers of sand to lower an obelisk into place with controlled precision. Picture this: a massive stone lying horizontal on a raised platform, its base hovering just above the pedestal socket. Below it, a chamber filled with sand supports the structure's weight. As workers slowly drain the sand through strategically placed holes, the obelisk descends millimeter by millimeter, guided by ropes to ensure perfect alignment. No cranes, no pulleys, just gravity and granular physics doing the heavy lifting. But here's the catch. While this method works beautifully in modern simulations, not a single grain of evidence has been found in the archaeological record to confirm its use. No remnants of sand chambers, no wear patterns on pedestals, no illustrations in tomb paintings. It's a theory that dances on the edge of plausibility, relying on materials, sand, wood, rope, that would have decayed long ago. The same problem haunts other lever-based hypotheses. Some researchers suggest the Egyptians might have employed cantilevered beams, using the obelisk's own weight as a counterbalance to pivot it upright. Again, the math checks out, but the physical proof remains as elusive as a desert mirage. What makes this debate so tantalizing is the sheer creativity of the proposed solutions. Another idea involves water-filled counterweights, enormous ceramic jars that could be emptied or filled to adjust leverage during the raising process. The concept echoes later Roman engineering, but if the Egyptians pioneered it, they left no trace of the apparatus. Even more speculative are theories involving wooden frames and pivot stones, devices that could have been dismantled and reused, leaving no permanent mark on the landscape. The silence of the archaeological record speaks volumes. If these techniques were commonplace, why don't we find fragments of the machines, sketches in scribble records, or even failures, half-raised obelisks toppled mid-process? Their absence suggests either an inconceivable level of perfection or a method so simple, so rooted in everyday materials that it vanished without a trace. Perhaps the real innovation wasn't in complex machinery, but in the Egyptians' unrivaled understanding of physics. They might have treated stone like a living thing, sensing when to push, when to pivot, and when to let friction do the work. Modern engineers have tried to reverse engineer these methods, often with mixed results. A 2014 experiment in Aswan demonstrated that a team using wooden levers and ropes could raise a 10-ton block, but scaling that up to 400 tons introduces forces that defy intuitive control. The margin for error shrinks to nearly zero, yet the Egyptians, without calculators or CAD models, consistently threaded that needle. Whether they used sand, water, or some lost technique, their true genius might lie in the invisible. A mastery of fundamentals so complete that even their tools seem to disappear into the act of creation. Every standing obelisk is a silent rebuke to our assumptions, a reminder that simplicity can outmatch complexity when guided by hands that truly understand their craft. From the sun-baked sands of Egypt to the highlands of Ethiopia and the heart of Rome, obelisks rise like ancient exclamation points across continents. The towering stelae of Axum, some reaching over 100 feet tall and weighing hundreds of tons, bear an uncanny resemblance to their Egyptian counterparts, yet they were carved 1,000 years later by a civilization separated by deserts and seas. How did these slender monoliths become a global phenomenon? The answer might rewrite what we think we know about ancient connections. Axum's obelisks share more than just a shape with Egypt's. Their precise tapering angles, intricate carvings, and even the way they were quarried from solid granite suggest either astonishing parallel innovation or a thread of shared knowledge stretching across Africa. Some scholars point to the bustling trade routes that linked the Nile to the Red Sea, where ideas could have traveled alongside spices and gold. Others highlight the mysterious land of Punt, a trading partner of Egypt mentioned in hieroglyphs possibly located near modern-day Eritrea or Ethiopia. Could Punt have been a cultural bridge, transmitting architectural secrets southward? Then there's Rome's obsession. The Eternal City boasts more standing obelisks today than Egypt itself, all plundered or replicated during the empire's heyday. But the Romans didn't just steal them, they reverse-engineered their own versions, like the obelisk of Domitian, carved from Egyptian-style red granite but inscribed with Latin. This wasn't mere imitation, it was a deliberate act of cultural alchemy, transforming symbols of pharaonic power into trophies of imperial conquest. The irony. While Roman engineers could build aqueducts and colosseums, they never quite mastered the original techniques. Their obelisks often cracked during transport or required external supports, flaws the Egyptians would have scorned. The plot thickens when you spot obelisk-like structures even farther afield. The Maya erected stelae in Mesoamerica, while in China, the Ming dynasty built ceremonial pillars with striking similarities. Could these be coincidences or echoes of a primordial human impulse to reach for the heavens? Some theorists whisper of a lost obelisk culture, a forgotten network of seafaring builders who spread their knowledge before vanishing into myth. Mainstream archaeology dismisses this as fantasy, but the nagging question remains: why do these identical forms emerge in unconnected civilizations? Perhaps the most tantalizing clue lies in what obelisks represented. Across cultures, they're tied to celestial worship, Egypt's sun gods, Axum's star-aligned stelae, Rome's solar emperors. Their shared shape might reflect a universal language of the sacred, a collective human instinct to carve the infinite into stone. Or maybe the truth is simpler: great ideas, like sunlight, have a way of traveling. Whether by trade, conquest, or sheer brilliance, the obelisk became a global signature of power and piety, one that still pierces the skyline from Cairo to Paris, silent sentinels of a world far more connected than we ever imagined. For the ancient Egyptians, building an obelisk wasn't just an engineering challenge, it was a sacred act, a collaboration between human hands and divine will. Every strike of the chisel, every pull of the rope was steeped in ritual. Before workers even touched the stone, priests would perform ceremonies to purify the quarry, invoking the god Min, patron of travelers and raw materials. These weren't mere formalities, they were believed to awaken the stone's spiritual essence, transforming it from inert rock into a vessel for celestial energy. The boundary between construction site and temple blurred. Each step, from quarrying to raising, was a liturgical dance performed with technical precision. Consider the stretching of the cord ceremony depicted in temple reliefs. Priests and surveyors would align the obelisk's foundation using stars and sacred geometry, tying astronomy to architecture in real time. The ritual wasn't just symbolic. It ensured the monument's alignment with cosmic forces, but it also served a practical purpose. By marking solstice points or stellar positions, they created a built-in calibration system, one that modern laser surveys confirm was shockingly accurate. This fusion of science and spirituality raises a provocative question. Did their faith give them access to a kind of knowledge we've since compartmentalized? Where we see separate disciplines, engineering, astronomy, religion, they saw a single, indivisible truth. The hieroglyphs adorning obelisks offer another clue. Far from mere decoration, these inscriptions often include precise accounts of construction timelines, material sources, and even worker shifts, details sandwiched between prayers to Ra and Osiris. One text from Heliopolis describes the raising of an obelisk as the moment heaven leaned down to earth, suggesting the act itself was thought to thin the veil between worlds. Such descriptions hint at a mindset where physical labor doubled as metaphysical labor, where every rope burn or calloused hand was a form of devotion. Modern experiments have shown that rhythmic chanting can synchronize team movements, reducing errors in complex tasks. Is it possible the Egyptians harnessed this effect, turning ritual cadences into a kind of prehistoric project management? The most tantalizing evidence lies in the artifacts left behind, or rather, the lack thereof. While we've found countless tools for shaping softer stones, the implements used to finish granite obelisks remain mysteriously absent. Some researchers speculate these tools might have been considered sacred objects, ritually destroyed or buried after use to prevent profane hands from wielding them. A fragmentary text from Karnak mentions the adze of heaven, a ceremonial implement used to open the obelisk surfaces. Could this have been a metaphorical reference to a lost polishing technique, one guarded as closely as temple secrets? Perhaps the ultimate testament to this spiritual technical fusion is the obelisk's longevity. While modern steel structures rust and concrete crumbles, these granite monoliths have weathered millennia with barely a scratch. The Egyptians didn't just build for their time, they built for eternity, convinced the stones would serve as permanent conduits between Earth and the afterlife. In that light, their perfectionism makes sense. A flaw wasn't just an engineering defect, it was a spiritual rupture. Every seamless joint, every mirror-like surface, was a prayer rendered in stone, a plea to outlast time itself. The irony is that in focusing solely on how they built obelisks, we might be missing the deeper truth why they built them. For the Egyptians, the answer was clear: these were no mere monuments. They were ladders for the gods, designed to last until the stars themselves grew cold. And in that unwavering belief, they might have unlocked something beyond mere technique, a harmony of purpose and craftsmanship that still defies explanation. The stones stand not just as relics of a lost technology, but as testaments to what humans can achieve when the sacred and the practical walk hand in hand. From the banks of the Thames to the heart of Washington, D.C., obelisks have transcended their ancient origins to become global icons of endurance. Cleopatra's Needle, standing proudly on London's Victoria Embankment, isn't actually from Cleopatra's era. It's 1,000 years older than her, yet its journey to England in the 19th century mirrors the mystique of the pharaohs themselves. Encased in an iron liner and nearly lost at sea during a storm, its survival feels like a modern echo of the Egyptians' own battles against the elements. Meanwhile, across the Atlantic, the Washington Monument soars skyward, its marble-clad form a deliberate nod to these ancient monoliths. But here's the twist: while it mimics the silhouette, its hollow interior and elevator shaft reveal a stark difference. Proof that even our greatest tributes to the past are filtered through the lens of our own technological age. What is it about these towering forms that compels cultures separated by millennia to replicate them? The answer might lie in their deceptive simplicity. An obelisk is just a four-sided pillar tapering gently toward the sky, no ornate carvings, no complex curves. Yet this very minimalism makes it a blank canvas for meaning. For the Egyptians, it was a sunbeam made solid. For Napoleon, a trophy of imperial ambition. For modern cities, a bridge between ancient grandeur and contemporary aspiration. Their power comes from what they don't say as much as what they do. Unlike statues or temples, obelisks don't depict gods or heroes. They are pure geometry, inviting us to project our own stories onto them. But the deeper allure might be their refusal to yield all their secrets. Take the Vatican obelisk, the only ancient Egyptian obelisk to never topple in Rome. For centuries, rumors swirled that its bronze globe contained Julius Caesar's ashes until it was opened in the 16th century and found empty. Even in defeat, the obelisk guarded its mysteries. Modern conservators still puzzle over the faint traces of pigment on its surface, suggesting it was once vividly painted, perhaps gleaming like a beacon under the Mediterranean sun. These lingering enigmas make obelisks more than relics. They're conversations across time, whispering questions we're still trying to answer. Perhaps their greatest legacy is the way they humble us. In an age of skyscrapers and space travel, these ancient stones remind us that precision and ambition aren't modern inventions. The Washington Monument, for all its height, would have been unimaginable without the prototypes carved in a swan 3,000 years earlier. Every obelisk standing today is a challenge cast in stone, a dare to match the vision of those who shaped the earth with nothing but copper, sand, and sheer will. They don't just defy time, they redefine what we think is possible, leaving us to wonder what other forgotten marvels might still be waiting in the desert's embrace. The idea that extraterrestrials might have guided the construction of Egypt's obelisks is a tantalizing escape hatch, a way to explain the unexplainable without wrestling with the complexities of human ingenuity. Proponents of these theories point to the precision of the carvings, the logistical nightmares of transport, and the eerie celestial alignments as evidence of otherworldly intervention. After all, how could a civilization without power tools or computers achieve such perfection? But this line of thinking does more than just stretch credulity. It erases the brilliance of the very people it claims to celebrate. Take the so-called tool marks that some claim resemble modern machining. While certain obelisk surfaces do appear unnaturally smooth, this ignores the painstaking methods we know the Egyptians used: abrasives like quartz sand, copper saws, and relentless polishing. The absence of obvious chisel marks isn't proof of alien lasers. It's a testament to craftsmanship so refined it rendered its own tools invisible. Even the famed granite boxes of the Serapeum, often cited in these debates, show clear signs of trial and error: misaligned drill holes, abandoned lids, evidence of human hands learning through repetition, not extraterrestrial blueprints. Then there's the scale argument. How could humans move 400-ton stones without cranes? Yet wall paintings and archaeological finds reveal a culture that treated engineering as a sacred art. They didn't need anti-gravity devices, they had leverage, sledges, and an intimate understanding of materials. The real marvel isn't that aliens might have helped, it's that the Egyptians solved these problems with nothing but observation, patience, and collective effort. Dismissing their achievements as too advanced for their time ignores the millennia of incremental innovation that preceded the obelisk's construction. What's lost in these fringe theories is the far more compelling mystery: how a society without formal universities or industrial infrastructure developed such sophisticated techniques through oral traditions and apprenticeship. The answers likely lie in forgotten methods, oral knowledge passed down through generations, experimental techniques lost to time, or even simple innovations we've overlooked because they don't fit our modern frameworks. The unfinished obelisk at Aswan isn't evidence of abandoned alien tech. It's a frozen moment of human trial and error, a reminder that mastery comes through failure as much as success. The danger of attributing ancient wonders to extraterrestrials isn't just scientific, it's cultural. It implies that certain feats are beyond human capability, a notion that undermines the ingenuity of civilizations outside the technological mainstream. The Egyptians didn't need visitors from the stars to inspire their monuments. They had something far more powerful, a worldview that fused the practical and the sacred, turning stone into celestial bridges through sheer force of will. The truth behind the obelisks isn't hidden in the cosmos. It's waiting to be uncovered in the sands of history, where human hands, not alien ones, left their mark for eternity. Ground-penetrating radar now hums over the sands where obelisks once stood, its invisible waves revealing buried foundations and lost quarry roads. In Luxor, laser scanners mounted on drones capture every chip and groove on standing obelisks with sub-millimeter precision, creating digital twins so accurate they've detected tool marks invisible to the human eye. These aren't just high-tech toys, they're time machines, letting researchers virtually recarve obelisks by analyzing wear patterns, or simulate transport methods using physics engines that account for variables the Egyptians faced: shifting sand, Nile currents, even the sweat-slicked ropes in workers' hands. One recent AI analysis of quarry marks at Aswan suggested an unexpected rhythm to the stone-cutting clusters of strikes matching optimal fatigue recovery cycles, hinting at a proto-assembly line system far more sophisticated than we'd imagined. But the real breakthroughs might come from where we least expect them. Forgotten storage rooms in Cairo's Egyptian Museum are yielding new clues as scholars re-examine fragmentary texts dismissed a century ago as ritual gibberish. One recently translated Ostracan, a pottery shard used for notes, describes a night of testing the balance before an obelisk raising, mentioning weights, counterweights, and a mysterious voice of the stone. Could this be a poetic reference to acoustic testing, where workers tapped the monolith to assess internal flaws? Meanwhile, in the Western Desert, satellite imaging has revealed what might be a previously unknown quarry site near the Karga oasis, its layout unlike any other. The exposed bedrock shows long, straight cuts matching obelisk dimensions, but the tools left behind include crescent-shaped copper blades unlike anything found at Aswan. The most tantalizing frontier lies in material science. Portable X-ray fluorescence devices have detected trace elements in Aswan granite that shouldn't occur naturally, nickel and cobalt in patterns suggesting deliberate alloy contamination. One radical theory proposes the Egyptians engineered the stone itself, using heated metal powders to alter its crystalline structure temporarily, making it easier to work. Experiments at MIT's Ancient Materials Lab have shown that certain mineral compounds, when applied to granite under extreme heat, can reduce its hardness by up to 30% for several hours. It's a controversial idea, but if proven, it could rewrite our understanding of ancient stoneworking worldwide. Yet for all our technology, some secrets may still lie buried in plain sight. The temple walls at Karnak depict scenes of obelisk transport that scholars once dismissed as symbolic: workers pouring liquid before sledges, priests holding strange T-shaped instruments. But 3D modeling now suggests these might be literal technical manuals. A virtual reconstruction of the liquid scenes showed that pouring water at specific intervals could reduce pulling force by precisely the amount needed to move a 400-ton obelisk with known Egyptian workforce sizes. Similarly, those T-tools, when modeled as surveying instruments, align perfectly with the astronomical orientations of the obelisks they're shown near. The next decade could finally bridge the gap between our theories and their reality. A joint German-Egyptian team is preparing to test a full-scale obelisk raise using only reconstructed ancient tools and methods, not as a stunt, but as a controlled archaeological experiment. Meanwhile, machine learning is scanning thousands of overlooked inscriptions for hidden construction terminology, building a database that might reveal lost engineering concepts encoded in religious metaphors. Every failed hypothesis brings us closer. Even disproven theories about extraterrestrials or lost super-civilizations have pushed researchers to seek more grounded, but no less extraordinary, explanations. What keeps the mystery alive isn't just the gaps in our knowledge, it's the dawning realization that the Egyptians may have achieved perfection through iteration we can't see. The unfinished obelisk isn't their only failure. Scattered quarry sites show abandoned attempts at new techniques. We're not studying a static tradition, but a living science that evolved over centuries. The real revelation may be that their greatest tool wasn't copper or sand, but time itself, generations of craftsmen refining their art, each standing on the shoulders of giants whose names are lost to history. As the desert slowly yields its secrets, one truth becomes clear: The stones still have stories to tell, and we're only beginning to listen. The architecture of Egyptian obelisks isn't just a relic of the past, it's a mirror reflecting the limits of our modern understanding. These towering monuments stand as silent witnesses to a civilization that turned raw stone into celestial compasses, defying time and gravity with every flawless angle. Yet for all our satellites and supercomputers, we're still piecing together their secrets, one tantalizing clue at a time. The unfinished obelisk at Aswan, the precision-cut pedestals of Luxor, the celestial alignments locked in granite, each is a breadcrumb leading us closer to a truth that reshapes what we thought possible. What makes these stones so endlessly fascinating isn't just the how, it's the why. The Egyptians didn't build obelisks to impress future archaeologists. They built them as bridges between worlds where geometry met the divine. Every perfect taper, every polished face was a dialogue with the cosmos. Today, we see engineering, they saw prayer. And perhaps that's the missing piece, a world where science and spirituality weren't opposites, but two sides of the same chisel. The greatest lesson these obelisks teach us: humility. In an age where technology makes the impossible routine, their silent grandeur whispers a counterpoint. Mastery isn't just about tools, but vision. We've split atoms and mapped genomes, yet we still can't replicate what they achieved with copper and sweat. Maybe the real mystery isn't the method, it's the mindset. How do you sustain that level of precision across generations? How do you carve not just for your lifetime, but for eternity? As the desert sands shift and new technologies peel back layers of the past, one truth remains: these stones aren't done speaking. Every scan, every translation, every experiment brings us closer to hearing their full story. So what do you think? Did the Egyptians possess lost techniques, or was their genius something far more profound? Drop your theories below and let's keep the conversation going. For more journeys into the heart of history's greatest enigmas, hit subscribe and join us as we unravel the next mystery. The past isn't just behind us, it's waiting to be rediscovered.